Okay, we will learn another type of problem in rectangles, that is shorter edge and longer edge problems. Okay, in the shorter edge problems, we have shorter edge problem. You can see this. We have two types of problems in rectangle. One is shorter edge and longer edge. So if it is in the problem they have asked to construct a shorter edge problem, means we have to consider a shorter length in the rectangle for the first position. Similarly, if they mention a longer edge in the question, we have to consider a longer edge in the first position. Okay, so that's what the first positions in the shorter edge and longer edge problems. Today we are going to learn another problem on longer edge. So you can see in the question we have to construct a rectangular lamina of dimension 20 mm into 30 mm. So rests on HP on one of its longer edges. So this problem belongs to the longer edge problem in a rectangle. The lamina is tilted about the edge on which rests till its plane surface is inclined to HP at 40 degrees. So inclination to HP given, and the edge on which it rests is inclined at 30 degree to VP. So both the inclinations were given. Only thing is we have to construct an rectangle with respect to the longer edge here. Okay. So we have to construct a rectangle here with respect to the longer edge. Here 30, longer edge here it is 30. So 30, 20. So this is A, B, C and D. Okay, so we construct the front view now. So here we got the B dash, C dash, A dash, D dash. So inclination to HPT is 45 degree. Take a reference point B dash, A dash. So marking at 45 degree. Okay, so we have to cut the arc from B dash to C dash. So this is C dash, D dash. So the angle we are getting here, it is 45 degree. So here A, B, C and D. So this is what the second position top view. Okay, now inclination to VP is 30 degree. Take a reference point here. It is 30 degree. So I'll take a reference here A. Okay, measuring the length from AB. So AD and BC, these lengths will be same. Now it is reverse. A to C. and B to D. Okay, now we will project it upward to complete the final position. So here it is A dash, B dash, C dash, D dash. So this we complete the problem in the longer edge in rectangles. Today we are going to learn shorter edge problem in rectangles. Okay, so we have to see the question first. You can see this rectangular lamina of dimension 35 into 20 mm. So we have to construct a rectangle of dimension. This rests on HP, so it is resting first position, resting on the HP on one of its shorter edges. So we have to construct an rectangle with the shortest edge here. Now the lamina is rotated about the edge on which it rests till it appears as a square in the top view. So it is similar to your isosceles triangular problem, wherein the second position is an equilateral triangle, right? Similar to it, herein they have not mentioned the angle of inclination to HP. Instead of that, they have mentioned a second position V. Okay, in the second position top V, we getting a square of dimension 20 we can construct. Now the edge on which the lamina rests is inclined to VP 30 degree. Okay, so in this first we have to construct a rectangle. Next, in the second position we will get a square of 20. Okay, and in the third position we have to incline it by 30 degree to VP. Okay, so we'll proceed with the question. So XY VP HP. So our first position start from the HP plane with respect to shorter edge. Shorter edge means here it is 20 mm. So I'll be taking 20 here. So this is 20 and here it is 35. 35 means 3.5 box. Okay, 3.5 box. This is 20. This is 35. Okay, now we can write the notations A, B, C and D. So we'll draw the front view. Okay, so B dash and C dash visible, but A dash and D dash not visible. So you can see in this problem they have not mentioned the second position. Instead of that they have mentioned we get a square in the top view. You can see that the lamina is rotated about the edge on which it rests till it appears as a square in the top view. So if we project it here, we get a square here, dimension of 20 here, see. So if we project it, we will get a square of 20 here. Okay, so we will get a square of 20 here, dimension. So first we will construct this. So it is similar to your isosceles triangular problem. Okay. So here it is A, B, C and D. Okay, now projecting it upward, we'll get the inclination to HP. Okay, so how much we have tilted the rectangle such that we get an angle here. Okay, so this is the reference point B dash, A dash. So we're measuring this length. Okay, it is similar to your isosceles triangular problem. Measuring this length, we are going to cut the arc. So we'll get angle here. So C dash and D dash. We have to find out how much angle it is. Okay. So can find out how much angle. So it is around 55 degree. Okay, 55 degree it is. Okay. So now in the third page you can see that the edge on which the lamina rests is inclined 30 degree to VP. So we have to first take a reference point. To this reference point, drawing 30 degree angle line. Okay. So 30 degree angle line. So we have to place this resting edge on this angle line. That's it. So take a reference of A. Now A to B. Cut the arc. Next from A to D. This is also same, right? All are 20 mm only. So this is B. Now reverse A to C and B to D. A to C. Okay. Then B to D. So this is D and this is C. Okay, now projecting upward, we can complete the first problem. Okay, so we get it here. This is A dash. So B dash we get it here. C dash is this and D dash is this. So we'll join these points to complete the final position. Okay, so this is how we complete the shorter edge problem in rectangles. We see another type of problem in rectangular lamina. Okay, in this problem also they have not mentioned any kind of inclinations. So based on the question we have to proceed with the solution. Okay, you can see in this question, first we have to construct a rectangular lamina of dimension 20 into 25 has an edge. So you can see in this problem, constructing a rectangle 20 into 25 has an edge in HP and adjoining in edge in VP. So that's what our first position. It is tilted such that its front view appears as a rectangle of dimension 20 into 15 mm. So that's what your second position. Okay. So now I am drawing the first position. So you can see in this first we have to construct a rectangle of dimension 20 into 25. VP HP. So here you can see that we need to construct a rectangle of dimension 20 to 25. We know that, so it will be there in the vertical plane because the next view is in front view, correct? So how we have to proceed? You can see that one edge has to be there in HP, another adjoining edge has to be there in VP. So what I will do, I will be drawing one edge that is 20, that is touching the vertical plane, another edge of dimension 25. So I am starting with the VP here. Okay, so you can see that 20 25. So you can see in this problem, so one edge is there in the HP plane, another adjoining edge it is there in the VP. So based on the question, has an edge in HP, okay, and adjoining edge in VP. So both the things are done. So now we'll show with the dimensions. it is 20, this is the 25. Okay, this is A dash, B dash, C dash, D dash. So here you can see that A, B, D, C. So this is what the front view. So front view also we get it on the same line. So we are done with the first position. Now we see that such that it is tilted, its front view is a rectangle of 20 into 15. So what we do in this problem is it is like this, like this. You can see that this like this. Say this is our first quadrant. Like this we have placed the lamina, and then we are tilting like this. Okay, tilting like this such that we get another rectangle of 20 into 15. So another rectangle of 20 into 15 we have to get it here. So if we project it here, okay, if we project it here we will get 20. So that means one edge we get it here, that is 20. Okay, another edge we get it, that is 15. 20 into 15 you can see in the question. So 20 into 15, 20 into 15, that is A dash, B dash, C dash, D dash. So this is what 15 and this is what 20. Okay, it's 20 and this is 15. Okay, so this is dimension 15, this is 20. So now we have to project to get the angle here. So we have, this is what A of B. So measuring this length from here to here, you can cut the arc. Okay, this is D of C. Then you can join this, can find out angle here. So the how much angle we will get it here, we'll check it. So the angle we are getting, it is around 53 degree. Okay, 53 degree. Now you see in the question, the edge which is in VP is 30 mm from the right profile plane. The edge which is in VP, right profile from the, so which is 30 mm from the right profile plane. So this is what the edge which is there in the VP, because A dash, B dash, A dash, B dash. So from this end we have to count 33 boxes. Say 3 boxes. This is 30, and exactly here we have to construct an x1 y1 line, x1 y1 line to find out the other view here. Okay, side view. So here I am marking at 45 degree. To get the side view we have to draw 45 degree angle line, correct? So this is 45 degree. So now I can project, okay, project it from both sides. You can see that where we get D and C. So D double dash here we get, and C double dash here we get, and then here you can see AB from this end, and we have AB. So A, it's the B double dash we get it here, and this is B double dash. So this is what was side view. So this completes your problem. So based on the question we have proceeded, right? So you can see in this question also they have not mentioned any kind of view here. Okay, any kind of view. So this is RPP, so this is left side view. So based on the question we have done this problem. Today we are going to learn another type of problems on rectangles. You see in this problem the top view of a square lamina of side 30 mm is a rectangle of side 30 into 20 mm. So it's like your isosceles triangular problem, wherein first we have to construct a square here, square of dimension 30, and your second diagram will be a rectangle. Okay, After that, we have to proceed with the longer side of the rectangle being parallel to both HP and VP. So you can see in this problem, they have not mentioned any kind of inclinations. Okay, there are no inclination to HP or VP. So based on the question given, based on the questions, we have to do it. First thing is we have to construct a square lamina of dimension 30. This is the top view. So top view of a square lamina means first projection will be in square, second will be in rectangle. Okay, rectangle of side 30 into 20. Instead of giving an angle, they mentioned the views here. Okay, first I will proceed with the question here. Okay, so you can see in this, first we have to draw an XY line. Okay, XY, VP, HP and Y. First we have to construct a square of dimension 30. Square of dimension 30 I'm going to construct. That is 4 boxes. Sorry, that is 3 boxes, right? So dimension 30 here. Square of 30 we have to construct. So this is our top view, A, B, C and D. So it is 30 mm. So the front view, what we get here, so front view we get it on this line. Okay, so that is B dash, C dash visible, but A dash and D dash not visible. Now you can see in this problem we have to get a rectangle. They have not mentioned any kind of inclination. Instead of that, they have mentioned a one weave, that is rectangle. So in the second position we are going to incline the square lamina such that we get a rectangle here, rectangle of 30 by 20. If I project from this side, okay, project from this side, so we will get a longer side of 30. Okay, we'll get a longer side of 30. So first I will get draw 30, then 20. We have to construct here 30 by 20, right? So 30 by 20 is the rectangle, that is A, B, C, D. 30 by 20 rectangle. So we can show the dimensions here. So this, we know this is 30 and this is 20. Okay, now we have to find out the angle of inclination. How to do it? Just projecting the lines upward here. Okay, so take a reference of here, this B dash and U dash reference. So by measuring this length from this B dash to C dash, okay, so we are going to cut the arc. So this is C dash and D dash. Now we have to join this after cutting the arc. Then we will find out how much angle of inclination here. So herein I am getting around 48 degree. Okay, so this is what the first position. Second, now we have to see, you can see in the question, the longer side of the rectangle being parallel to both HP and VP. So longer side of the rectangle, so this is what the longer side of the rectangle, right? 30 mm. This is what you have to make it both parallel to HP and VP. So in this position it is parallel. Okay, it is parallel to HP. Now we have to make it parallel to VP. How to make it parallel to this? What is this edge AB? It is parallel to HP now. Okay, so this position it is parallel to HP. How to make it parallel to VP means we will take this AB side here like this, we'll draw like this, so that will become parallel to VP. So you can see in this here it is 30, right? So 30 right here, 30 by 20, right? 30 by 20 rectangle. These are 30 by 20. So this is B, A, T, C, correct? So yes, so we have done. So now we can see this AB end, which is parallel to HP, now it is become parallel to VP here. So now we will project it upward to complete the final position. So in this you see it, so B dash not visible, and C and we have C dash, we get it here, and D dash we are getting here, and A dash we are getting here. So this is what the actual final weave. Okay, so now we can see in this question, draw the top and front views of the lamina. You have to find out the inclinations. Okay, inclinations of the surface of the lamina with HP and VP. We got one inclination, that is inclination to HP. To find out inclination to VP, what we do here, in first we will draw an x1 y1 line. Okay, x1 y1 line. Okay, we'll draw 45-degree angle line here to this reference point, to this point. Okay, so this is 45-degree angle line we will draw. Then we have to start from this top view until it touches the 45-degree angle line. Okay, then we have to project it upward. It is touching. Okay, so then from this front view also, so we have to project. Now we have to see where the top view notations and the front view notations are merging. Okay, here we get, you can see that here, exactly here at this point, we have B double dash and A double dash. Similarly here, exactly at this point, we have C double dash and T double dash. So this is what our side view. Okay, this is what our side view. Now we can find out, this is what the angle of inclination to HP, this is what the angle of inclination to VP. So if you just measure it, so already we have got this is 48 degree, right? This is 48 degree, so this is 42 degree. 48 plus 42 means 90 degree. So this is how we completed the problem. Okay, parallel to HP here, now it is parallel to VP. That's how we have proceed in this problem. Good morning. We see another problem in rectangular lamina. Okay, we see the question in this. So what is given in this question is the front weave of a rectangular lamina of sides 13 to 20 mm is a square of 20 mm side. So that's it. They have given only this thing. The front weave of a rectangular lamina 30 mm into 20 is a square of 20 mm. Draw the projections and determine the inclination of the surface of the lamina with HP and VP. So in this problem, they have not mentioned either any of the inclination to the HP or to the VP. They have mentioned only the second view. Second view will be in square. Okay, so that is occur only in the front view. So this problem will be proceed with respect to the differently. So I'm going to show it how it is. Say if you consider this is your first quadrant, so the lamina will be placed like this. Okay, lamina will be placed like this, and the inclinations, okay, the inclinations what we give, okay, so what we give, it will be like from this end, say it is like this, so it will be fixed to the one end in the first position, the second inclination like this. Okay, so the inclinations we can see only with respect to the side view. For that we will be drawing an x1 y1 line. Okay, so x1 y1 line will be drawn in this, and we are going to find out. Okay, so this problem will be proceeding like this. Say just show it how it is. VP HP. So here we draw, okay, rectangle of dimension 30 to 20. So the first view, second view, we get it here. So in order to find out the inclinations, what we do, we will be drawing x1 y1 line here, and we will be drawing 45 degree angle line and then projecting it here, we get the angles. Okay, so that's how the problem proceeds. Okay, x vp is, so in this first we construct a rectangle of dimension 30 into 20, that is 3 boxes, 30 into 20. Okay, so this is a dash, b dash, c dash, d dash. So the top way we get it on this xy line only, a b d f c. Now the second view is a square. Okay, square of dimension 20. So we will construct it, that is 2 by 2 box. Okay, so we can show the dimensions here. So this is 30 and this is 20. Okay, and also 20. So 20. So this is a dash, b dash, c dash and d dash. So herein we have to find out the angle of inclinations. Okay, so how we find out here is, we will be drawing in here x1 y1 line. Okay, x1 y1 line, and we are going to project these side views. Okay, project these side views. Okay, how we do it, like the side view of this lamina first position will be lying on this x1 y1 line. Okay, so that's what the side view of this first position. So what we get here is a double dash, d double dash, b double dash and c double dash. This is what the side view of the first position. Similarly for the second position, so what we have to get the side view here is, so projecting here, so we know that, so this is what the first lamina, by inclining it at how much angle we don't know, we're getting a square of 20 by 20, right? So this is what has been inclined like this. So it has been inclined like this. Say this is our first quadrant, means say this is our rectangular lamina, this has been inclined like this. So right, it has been inclined in such a way that we are getting a square of 20. So whatever the inclination is there, we can show it in the side view. Okay, how to show it in the side view means, so say this is what the side view of the first position, a double dash, d double dash, b dash, right? So this is what the side view. So this side view we are going to incline it with the help of arc. Okay, with the help of arc. So here exactly at this point we are getting the side view of the second position. Okay, so this is what the side view of the second position. Okay, so now we can get the angle here. So this is what the angle for the both the inclinations. So we can write down this. So the one angle of inclination here, it is 42 degree and this is 48 degree. Now we have to draw the top view of this. So what we do is that we will be drawing an angle line here. 45 degree we have marked angle line. Okay. So we're projecting it downward. We get the another view here. Okay, so here we get it A, D, B, C. So this is what we completed with the problem. Okay, so in this position first we have drawn this one, and top view. Second, after that we have drawn this one. Okay, then after that we have drawn an x1 y1 line to draw the side views. The side view of this, it is falling on the xy line, and the side view of this, it is falling here. By taking this, because we are inclining this in such a manner that we are getting the top view, so that's why we are inclining it by means of an arc. Here I'll be showing the direction of the arrow mark. Okay, inclining it by cutting the arc, we're getting the side view of this position. So by doing it, we get the both angles. For the angle of inclination to HP, angle of inclination to VP, then the top view of this position we are getting by drawing an 45-degree angle line. Okay, so drawing a 45-degree angle line, we are getting the top view of this position.